Alright, so the lab was get a paddle that moves up and down and then constrain the paddles to the screen so you can't move them outside the screen. Alright? So what I'm going to do is I'm going to close this guy here. The moving part is basically what we've done in previous labs. However, I did want you to consider using delta time to move the paddles so that they move at a consistent rate. Otherwise, the amount that they move is kind of variable based on the frame rate that you have. So, whereas before we just called move and didn't even really care about the specific rate at which the paddles move, in a game of Pong or like in any game, you really want to have specific control over the rate at which the objects are moving inside your game. All right. So what we're going to do is we're going to set up two rectangle shapes. Oh, and you know what? Like I think I'll do this. I'll show you two ways, one with using arrays and one without using arrays. But we'll do player one here. And rectangle shapes here take a size, so I don't know, like 30 and 100. And I'm going to make a player two as well. And in player one, I'm going to set his fill color to be red. And then, oh, there are two ways to set color. You can set color by specifying RGB. I talked about this. Or you can specify color using these predefined constants here, like red or blue. Your choice. I'll do it both ways, so we can see. And what we'll do is we'll set up their positions here. Their initial position. Player one will be on the left here. And I'm going to offset him maybe 30 pixels, and then put him at, I don't know, whatever, 512 times 0.5 plus half the width of my rectangle. So it's kind of like, this is 256 plus 50. So put him kind of halfway on the screen. Same in player two. I'm going to have him 30 pixels off the edge of the screen. So 1024 minus 30 off the edge of the screen, minus another 30 for the width of the player. These two, this right here is just basically making it so he's off the right side of the screen. And then we'll just draw player one and player two. So we have player one and player two. Oh, and I want this thing to be minus 50, not plus 50. So that I have my two chubby rectangles here, and I want to just have them move up and down based on whether I press a key. So first things first, I want to have, if a key is pressed, W, I'm going to take player one and move like so. So now I'm just calling player one, I'm moving him up in negative 0.1f, like so. Okay. I do want to show at this point as well that you don't have to actually call move. You can do it yourself as well. You can call set position here. You can call set position instead of calling move. It's a little bit different. Where set position tells the SFML exactly where you want this thing to be. If you want to do that, you do get position.y minus 0.1f. You can call set position passing in the current position of y, subtracting 0.1f from it. That's exactly all. That's all that the move function call does, is it moves you relative to a position. Oh, I also did not set this here. 30, which would be player one that get position dot x. You can do it this way as well. This is exactly the same as calling move. Okay, these are identical to one another. Okay. Move is just a little nicer that lets you get to exactly where you want to go without having to do all this. Okay? Keep in mind this is just an alternate way. All right, so let's set up down as well. So S, so positive. Get rid of this alternate method. So now I can move player one up and down, like so. And I'll do this for player two as well. Okay, so there's my if statements for moving both players. So now my keyboard and my W and S key move the players like so. So now let's bring in delta time. Because how many pixels per second is this moving? Well, who knows? I don't know. That's probably 300 sometimes, but it depends on if I currently have something happening in the background. So he actually slows down moving if I'm wiggling stuff in the background, and he speeds up if I have stuff in the foreground. So like here, see how he slows down? It's not something we want to do. So instead of doing negative 0.1, what I want to do is consider the fact that time passes, and I can keep track of that time that passes between each frame by restarting the clock, and restarting the clock tells me how much time passed since the last time I restarted it. So now I do this instead of this. I can do negative 300 pixels per second. Take this as my formula here and plug that in instead of negative 0.1. So now it doesn't really matter. So now my paddle will move the same amount whether or not I am doing stuff in the background. Okay. All right. Cool. So let's talk about constraining player movement. So whenever the player wants to move, we just go ahead and move him. We don't care. We're just like, sure, go ahead and move that amount, 300 pixels per second. That's how many I want you to move. However, we want to constrain it so that we don't always let him move, particularly when he's off the edge of the screen. So right after we detect that he's currently holding a key, what we want to do is have an if statement here. And this if statement here is going to control whether or not he's allowed to move. Right now, I'm setting it to true by default, which means I'm always letting it move. However, what I really want is to go back to my example here and say, hey, if he's off the top edge of the screen, ignore the movement. Don't let him move. So if I get the position of the player, and the position is comprised of an X and Y component, I grab the Y, and as long as this position is greater than or equal to 0, that means that I'm allowing him to move. That's the only time I'm going to let him move. If his current position is currently above the edge of the screen, I'm sorry, below the top of the screen, that's when we're going to allow him to move. What happens though? So watch what happens here, and I'm gonna take a little side tour and talk about why I know how to do this. Because watch, I can't move him up anymore. He's stuck. So I want you guys to know that a lot of programming and game development is about getting information about what's happening. It's really sometimes pretty confusing to get an idea of what's happening in your game just by looking at the game and then trying to figure out what's happening in the code. Like looking at here and be like, oh, why is he going below? Or like, I don't know where he is exactly. Writing logic that corresponds to that sometimes can be tricky, which is why it's actually really beneficial to use the computer to your advantage and have it do the work for you to tell you what's going on. Whenever you're stuck in a state where you don't know what to do, I highly recommend you guys using couts or printf statements to print the state of your objects in your game. For instance here, before I had this if statement, and I just want to get an idea for like what the player position is, I could just print out the player position. I could just print it out every time I run a frame. So why don't I just print out the player position here, and here, in between. This is also why printf is a lot nicer, because you can do this really fast. Let's print it out in between here. So I'm just going to print out the player position by getting the X and Y component of it inside my cout statement. I'm just going to print it out every frame, because I don't necessarily know what I want to do with my collision statement, but I do know when it looks wrong. So here's the current player position on the left. I'm just going to have that thing running. So as I'm moving up and down, you see that thing changing. And look at that Y component, the second component of that print that I'm doing. See how I'm doing that, and now it's negative 15? And you can see it's going negative. So like I get an idea that when that thing goes negative, that's when he's above the screen. So I only want him to move up if he's positive. Same with going down here. So it looks like he's around the 410 mark. 411, 412 mark. That's actually is 512 really. So when I'm below 412, that's when he's below the edge of the screen. So I get a good idea of the position of the player just by doing this. Okay. So then if I write my code here, again, get position.y is greater than or equal to 0. That's the only time I'm going to let the player move. So look at that y position again. I'm approaching negative. Bam. So I'm currently hitting up, and my value is negative, so I'm not allowed to actually move up anymore. Look at my position here. It's actually below 0. Every time I go up, I get below 0 just a little bit. So now you can see that, oh, my y position isn't changing because this if statement is returning false. Watch what happens. I'm going to put a breakpoint in here. Okay. So those breakpoints, it's running right now. So that breakpoint will hit whenever I hit up. So I'm going to go to the top edge of my screen. My position is negative 0.034. Put a breakpoint right here while the program is still running. And I'm going to hit up one time. And now execution has stopped and the focus has switched to my debugger. And now I can see the player position. I can just hover over this player position. And I can do this. So you guys can see, let me put the position up here. There's the position right here, negative 0.034. And that value, which I'm getting, the y position, which is negative 0.034, is not greater than 0.0f. So this if statement doesn't run. So I don't move. So it is kind of a problem that he's negative right here. So I think in the case where he does end up being negative, what we can do is we can actually just reset his position here to be 0 exactly. So if I just write an else condition here that says, hey, if you end up being negative, what I want to do is do player1 set position, get the current position of the player, set his x position to be the same as what it currently is because we're not moving him horizontally, and then just reset his y position to be 0. This way, whenever he moves up and he's negative, I'll immediately correct him to be back to 0. Like so. See how it's being corrected here? So kind of being bounced out of there. All right. Any questions so far on this stuff? What we can do is, now that we have this, I don't really like the bouncing part because I don't like the fact that he's bouncing all the time. So what I can do is, the reason why that's happening is because it's only doing this behavior when I'm pressing a key, and it's doing this like late. So right before I do all this, oops. I can set up an if statement outside of this so that even if I ever move him outside, it'll not let him actually end up outside. So here now, I'm actually doing the correction after I've moved. So I let him move first, let him move for like a split second outside, and then I correct him. Okay. You can't even see it. Like, you can't see that it's popping at all. It actually just doesn't let him move.
And it doesn't show that on the console either.
Right, because I'm only printing it out here before I do any of the move stuff. Okay. All right, so let's set up the rest of these. How do I test to see if he's off the bottom edge of the screen? It's the same general idea. However, I can't just test the position.y is greater than 0 because 0, the bottom edge of the screen here is 512. So what I need to do is only let him move if he's less than or equal to 512, right? So 512 is the bottom. this will constrain him to be on the bottom here. Oops. Let player 1 is less than 512. Yes, this is the bug. This is what I was trying to show. So he goes off the edge of the screen. He's actually here. He's at the bottom. But it's only constraining the top left corner of his rectangle, like I mentioned earlier. So it's not actually 512. It's actually 512 relative to the position of the blue circle, like the bottom edge of the rectangle is what I want. So I need to take into account the fact that this thing has a height. So what I can do here is if I get the position and I add in the size, okay, now the size is being taken into account here. And now the bottom edge of that rectangle is there. This size here is just whatever I typed in above, so I could literally do 100 here. That would also work. Either way. And this size directly influences what I consider to be the bottom of the player. Okay. Questions so far on that? So we're just going to duplicate this here. And then I'm going to show you some alternate ways you can do this too. I'm just going to repeat that. So now player 1 and player 2 are both doing that. And then I'll set up the correction stuff too. So now player 1 and player 2 are both bound. So there's our Pong paddles. Okay. And then we can set up this 4 times. So fix this. Okay. There's my statements to correct the player. There's a lot of these statements there, but I'm just really copying and pasting all the behavior that I had before. Oops. That's also a problem. So this is also because I'm setting the position to 512, which is not correct. I want to set the position to 512 minus the size of the rectangle. Here and here.
And you did player 1.
Oh, thank you. Well, that actually doesn't matter, but you're right. That is correct. The reason why we do all this stuff here is now our collision will work no matter what the size of our paddles are. So if I go in here, I change my paddles to be 200 by 200, like super, super big, it really doesn't matter. The paddles will still respect the collision boundaries of the top and bottom. Kind of the weirdest game of Pong you've seen. Or they could be super tiny. Just little squares. And it still works as you would expect. This will also work for like super, super thin ones. I think it'll work for 1 pixel. I think 1 pixel wide, maybe half a pixel wide. I don't know if it actually draw half a pixel wide rectangles. Oh, it does. But see, they're actually still constraining in here. You can't see them. You can only see them when they're moving. Sometimes they end up on a full pixel boundary. It doesn't quite work. Anyway, so like that logic will now work for any size that you have, which is the nice part about doing it that way. Okay. All right, questions on that? I would actually like to go over more ways to do this. There are plenty of different ways to handle player movement in Pong, but this is just the most straightforward way. All right, let's talk about lab number 2. And I'm just gonna continue straight on in the recording here. So what I want to do now is I want to have a step-by-step process in how we get a ball in here and interacting with the paddles. Okay, so The first step is we're going to make a ball that bounces off the top and bottom walls. Okay? So this means that I want the ball to move at an angle, actually, just like what we had for the cannon, so at an angle, just like in Pong. But I only want it to bounce off the top and bottom walls. So that ball, that logic for the ball bouncing off the top and bottom walls is actually exactly the same logic that we just used to constrain the paddles to the top and bottom. What you actually just did when writing the constraining behavior was you wrote collision detection for the top and bottom of the screen. You actually had the paddles colliding with the top and bottom, and you did something about it when they were colliding. So the ball collision is the same concept, where you want a ball that moves. You want to have a velocity on the ball, just like what we did for the cannon, the homework, the lab last week. And I want it moving at an angle, but I only want it to bounce off the top and bottom. Now, bouncing means that the ball, if I delete this, if I make a brand new one, is my bouncing means my ball is moving at a specific velocity and then hits and bounces off. Okay? It doesn't bounce off the left and right. That's not how Pong works. But if it goes like this, it bounces off the top and bottom. So the bouncing part is actually probably the easiest part about this, which is that once you detect a collision, all you have to do is flip the velocity in the y direction. Whereas if it's moving down and to the right, remember what we said the velocity of y was if it's moving at 100 pixels per second this way? This is 100 pixels per second. The y component velocity at 45-degree angle is like 70.7 something. If it was moving down at 70 pixels per second, if you want to move up, you just have to multiply it by -1, and that goes up then. So this thing here now goes up, right? That's where the ball is going. So when I say flip, when I say bounce, I really just mean flip the y component of the ball. Okay. So the second part is now we're going to write behavior to detect when a mouse is over a paddle. This is kind of a stepping stone to doing the ball collision. You have a mouse, and I want you to act like the mouse is the ball that you control, basically. And what you need to do is you need to write some behavior so that when the mouse is over one of the rectangles, it turns the rectangle white. Okay? And I want you to repeat that for the right and left paddle. I'm going to talk about how to do that in just a second. Once you have the paddles reacting to the mouse, what I want you to do is I want you to have the paddles turn white when the ball is inside them. Because if you think about the ball, it's really just a mouse cursor with, it's just a little chubbier than that. It has a little bit of a radius associated with it. But the behavior for detecting whether that ball is inside that paddle is the same. So once you have them turning white and the ball is turning the paddles white, now what you have to do is just make it so that instead of turning the paddles white when the ball is inside them, you flip the x component of the ball's velocity. And that'll make the ball bounce off of it instead of turning the paddle white. Okay? So how do we detect if the mouse cursor is inside one of these paddles? If I have my paddle here, and I have my blue paddle here, and I have my little mouse cursor here. Okay. So how did it detect if that thing is inside a rectangle? Okay. Well, when you are detecting collision for a point against a box, how do you know whether something's inside the box or not? It's kind of obvious, right? Like, if this thing is fully encapsulated by the box, if all four sides are outside the box, or outside the cursor, right? So I have this little guy here. Too small. Too small. I have this little guy here. And this right here, he's not inside the box, right? Now, this is kind of the classical problem of becoming a programmer, is how do you take what you know as a human, as a person, and how do you translate that into something that you write as code, right? Because I know that everyone here understands when that mouse cursor is inside the box. I know that you guys know. The problem is can you write down the steps that you took mentally to determine that that arrow is inside the box? Okay, that gap of being able to take what you know and write it down line by line, even just on a piece of paper, that is the thing that you guys need to practice. Right? That is the skill that I can't teach you. That is something that comes with practice and patience and studying. This is the kind of stuff that you have to basically do over and over again. But I'll help you as much as I can with this case here. Okay? I'll go through my mental process of how I know whether the arrow is inside the rectangle or not. Because even though this is a very simple example, this is the same exact thing for any problem that you have. Anything that you're making, anything in a game, let's say I want to make an MMO. Well, I know what an MMO looks like in my head, but how do I translate that into something that I can actually write as code? Now that's a much bigger example, and I'm not saying that that's like something that you can easily do, but that exercise of converting what you know you want to like something that you write in code is the thing that you have to practice, and that's what the gameplay programmers do. So in this case here, I have an arrow, and I know when this arrow is inside because it looks like it's inside. What does that mean, that it looks like it's inside? Well, that means that this arrow, the position of this arrow here, is fully encapsulated by all four sides of this rectangle. So for instance here, I know that that's not inside the box. I know that that's not colliding with the box because even though it is actually between the top and the bottom parts of the box, and it's between this and this, the left side here, I'm going to shade the areas that is actually inside. So like if I actually do this, so this arrow here is below the top part of this box, right? That's what I'm drawing here. This arrow is below the top part of this box. So if I had this imaginary line here, I'm going to draw imaginary lines for all of these. Okay. I'm just going to draw out these lines to fully extend. You can kind of see that this arrow can actually belong in any of these 9 places, right? That arrow can actually live kind of like if I draw these lines everywhere, can kind of live in any of these places here, 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 around the box. But it's only technically inside the box if it's in between the intersection of all of those, right? So if I break this down and say, hey, my rules for whether I consider this arrow to be inside the box or not is based on where it lives relative to each side of the rectangle. So I can come up with a set of rules. I'm going to say that this arrow is only colliding with the box if it's below this top part. I'm going to call this thing top. If it's above the bottom part, bottom, and this is going to be left, and it's going to be right. I'm going to say this arrow has to be below the top of this rectangle here, and it has to be above the bottom of the rectangle. It has to be to the right of the left side here, and it has to be to the left of the right side of the rectangle. So what I mean is that if I look at the position of it relative to the top, bottom, left, and right of the boxes, I can say that this arrow is only colliding with the rectangle if all 4 of these sides match those criteria. So I look at the position of the arrow, and I'm going to compare it to the top here. Let's take a simple example here, and let's see when it's not colliding with the rectangle. Okay? So when I have this thing below the box here, I know that it looks like it's below the top of the rectangle, and it looks like it's between the left and right, but it's not above the bottom part here. So it doesn't match all 4 criteria. It has to be matching all of those criteria. Otherwise, it's not considered a collision. Okay? So, when you're writing your condition for whether the mouse is inside the rectangle or not, you have to consider all 4 sides, which means that you guys are going to be writing an if statement, and I gave you guys a little bit of a helper. I gave you guys a little snippet of code that does 2 of the 4 sides for you. Okay? This snippet of code will tell you whether the mouse is between the left and right sides of the rectangle. So basically, it will tell you if it's between, if the arrow is anywhere in here. Okay? That's what the code does. What I want you to do is to combine that and make sure that you're only doing it when you're anywhere in here. Okay? Inside the 4 boundaries of the rectangle. Okay. So that's lab number 2. And I give you a picture of what it kind of looks like with that. Once you have the mouse working, then you're going to replace the behavior of the mouse with, instead of getting the position of the mouse, you're going to get the position of the ball instead and use that for the collision detection. It's the same exact concept, except you're going to use the ball. Okay? All right, so go for it. Oh, and if you guys need this, I'm going to put my paddle code on Zool so that you guys can use this. If you need a starting point for the ball collision stuff, I put a CPP file on Zool called lab. You guys can use that to start so that you have some paddles. Yes?
So when you say when we create the mouse position, you want us to replace the mouse position to ball?
Yes. I want you to replace it so that the mouse doesn't do that behavior anymore. The mouse is kind of like the first step, and then now that you have the mouse working, then you just replace that mouse with the ball position, and then it should just work.
So it should just move on its own favor.
Yeah, I want a ball that looks like from the homework, kind of, where the ball kind of moves in a direction. Okay?
This brings me back.
Yeah.